Here we will be doing about the probability distributions. So when it comes to probability, probability means uh, something happen or not. In Sinhala we call it as Viya Hakiyawa. Actually, whether an event occurs or not. What is the probability කියලා කිව්වම probability කියලා කියන්නේ a proportion එක in numerics. So anyway, here we will be discussing about the probability distributions. No? For this probability distributions, what do we have? The first part is the random variable. We should know what is random variable. So for this random variable, a random variable is a quantitative variable whose value depends on chance. The chance means actually the probability, whether it will happen or not, whether it will happen or not. So here for a random variable is a quantity, and also you should know that this random variable is a quantitative variable whose value depends on chance. So when it comes to this random variable, we can divide. If it's a numerical one, we can divide into two categories. One is the discrete random variable. The other one is the continuous random variable. One is discrete random variable. The other one is a continuous random variable. The same method, the same theory part we can apply here as well, because for the discrete random variables now, the random variable should be countable as 1, 2, 3, 4, 5, 6. But if it's a continuous random variable, now there should be a range. We will not be able to countable. ඒ කියන්නේ අර intervals එක තමයි යන්නේ for those continuous random variables. හිතන්නකො මේ random කෑල්ල අයින් කළොත් may numerical variables, anyway we can divide into two categories. One is the discrete category, the other one is the continuous category. The same approach we can apply here as well. Now for the discrete random variables, there we have value is obtained by counting. These value, when it comes to these values, value is obtained by counting. And as I told you, that's what they are, even I explained. But for the continuous random variable, value is obtained by measuring. We can't count it as 1, 2, 3, 4, 5, 6. We have to measure. There, the precision matters. Precision or the decimal matters. So, then for the discrete random variables, see the example. Frequency and relative frequency distributions for number of siblings for students in introductory statistics class is given below. This is a frequency distribution table, frequency table. We know it. So here we have the siblings, whether they have any other sisters or on sisters or brothers. So for the siblings 0, 1, 2, 3, 4 කියලා they have counted it. ඊට පස්සේ for the frequencies කවුරුත් නැති තනි ළමයා in person එයා විතරක් only child අය 8ක් ඉන්නවා. One siblings 17, two siblings 11 and three siblings. So ඒ විදිහට we can count out. And the relative frequencies will be 0.2, 0.425, 0.275. Likewise, they have calculated the relative frequency. මෙන්න මේ relative frequencies ටික add කළාම, if we add all these relative frequencies, it should adds up to 1. It should adds up to 1. How do we measure these ones? For example, suppose now that a student is selected at random. They ask us to think that a student is selected at random. Then the number of siblings of the student obtained is called a random variable. We should be able to define the random variable first. So the random variable definition according to this given context will be number of siblings. Always this random variables the random variables definitions should start with the number of. හරිද? එතකොට number of siblings or if it's a count count of එහෙම කියලා with that term only we are starting these random variables. So siblings of the student obtained is called a random variable because its value depends on chance and then because its value depends on chance, namely on which student is selected. That's what we have. So here, then we have the probability distributions. Then here we have the probability distribution, a table of all the possible values and corresponding probabilities of a discrete random variable, or a formula for the probabilities will be there. And for the probability histograms, then for the histograms, we can, for the random variables, we can draw the probability histograms as well. So a graph of the probability distribution that displays the possible values of a discrete random variable on the horizontal axis and the probabilities of those values on the vertical axis. For example, if it's something for the previous example, what do we have here? We have two axes. One axis will be x-axis, the other axis will be the y-axis. So for the x-axis, a graph of the probability distribution that displays the possible values of a discrete random variable. Possible values will be values of a discrete random variable on the horizontal axis and the probabilities of those values on the vertical axis. When it comes to probabilities, so you should measure the y-axis from 0 to 1. It can be either the number of siblings 0, 1, 2, 3, 4. Likewise. Is it clear what I'm saying?
Yeah. Yes.
Okay. So then variable on the horizontal axis and the probabilities of those values on the vertical axis. Then the probability of each value is represented by a vertical bar whose height equals to the probability. See the example. Discrete probability distributions. Refer to above example and let X denote the number of siblings of a randomly selected students. So here for the discrete probability distributions, these ones refer to above example and let X denote the number of siblings of a randomly selected students. What does they mean that? So the first question is determine the probability distribution of the random variable X. Okay. See the siblings counts මෙතන තියෙනවා. How do we calculate the probabilities? What do you think? To count these probabilities with these values, what do you think? How we get the 0.2? Relative frequencies. That is the probability. So for these kind of ones, what they have done, they have divided this 8 by the total number of frequency. 8 over 40. So 8 over 40 means 1 over 5. 1 over 5 means 0.2. Okay. Then for the second one, 17 over 40. Then for the second one, 17 over 40. Third one, 11 over 40. We are calculating the probability. Kaurut natuwa, siblings natuwa, only child we may probability occur. So it would be 8/40. That's what we have the relative frequencies. Those are the values we have for relative frequency: 0.2, 0.425, 11/40, it will be 0.275, and 3/40, and 1/40. These relative frequencies adds up to 1. That means these are the probabilities. How do we measure, how do we denote this one? That is for the probability. Now we have defined the random variable x. Okay. So the capital, how we define the random variable anyway, it should be in capital X. Capital X is the number of siblings. Now the probability will be this capital X should equals to what are the values this capital X can be taken. These are 0, 1, 2, 3, 4. Now probability capital X is equals to 0 will be equals to what? 0.2. Then you can calculate probability. Oh, why it's not working? Okay, make it. Probability, then wait. Probability, then this x. X means you can't have this x actually. You have to write the capital X. So the capital X should be 1 is equals to what? 0.425. So these ones are the values which we can have for the random variables. Make a define karanne with the simple X. ඇත්තටම notation එක, if we consider about the notation, probability, capital X should equals to simple X. Okay.
Miss, X is probability.
No, X is not the probability. This is the events actually. May capital X කියලා කියන්නේ X. Capital X means the number of siblings. That is the random variable. Number of siblings. So the number of siblings, that is the capital X. What are the values which we can have for this capital X? That is 0, 1, 2, 3, 4 කියලා කියන හතර. So these values are we denoting with the simple X. එතකොට මේක කියවන්නේ when the probability of random variable X is equals to 0, X is equals to 0, probability when the random variable X is equals to 0 should be 0.2. Probability when the random variable X is equals to 1 should equals to 0.425. Probability when the X is equals to 2, okay, probability when the random variable X is equals to 2 will be 0.275.
Okay.
Likewise, this X is not the probability. X, capital X is the random variable. Simple X is the values which we can have for those random variables. So probability, අපි කොහොමද කියන්නේ if we have a notation now we have probability of A, the event A නේ. ඒතර මෙතන කියන්නේ තේ event එකක් තමයි. Here we denote that event. Okay? So then see, so the probability, capital X is equals to simple X. When it is 0, that means 0.2, 1, 0.425. Then we can have the number of siblings as in x-axis, and the probabilities, we can denote it with the y-axis. So the maximum probability we have is 0.425. We have the 0.425. They have marked it from 0.05 to then this is a normal histogram bage case. We can denote it, we can draw whatever we have like this. Is it clear?
Yeah.
Okay. Shall we do the example? So, okay. So for the example, discrete random variable probability distribution. Okay. Now, if the experiment is a random variable එකකින් experiment එකක් විදිහට ගන්න යන්නේ, if this is the case, what do you think? What we can have as the random variable? We are tossing a coin. Toss
Yeah.
2 coins, right? Here the experiment would be tossing 2 coins. The random variable x would be either
Head or tail.
no. Head or tail are the events. Either it can tail head or either it can turn head or either it can turn tail. Those are the 2 events. But for the random variables now, as I told you, we have to start with the number of. So if we write all the opportunities or else all the elements in this set, if we are tossing a 2 coin, it can be either 2 tail. දෙකම tail වෙන්න පුළුවන්. And first coin එක tail වෙලා second coin එක head වෙන්න පුළුවන්. And first coin එක head වෙලා second coin එක tail වෙන්න පුළුවන්. And at last we have both as the head. දෙකම head වෙන්න පුළුවන්. So this first coin is for the first coin. The second coin is for the second coin. එහෙනම්, according to this given structure, how we can define the random variable, that is, අපි x කියලා random variable එකක් define කරොත්, if we define a random variable called x, then it can be either number of heads, එහෙමත් නැත්නම් it can be number of tails. So if we take it as number of heads, for this case, we don't have any heads. So එහෙනම් that is when capital X is equals to 0 event. So for these 2 cases, capital X is equals to 1 because we have only one value. Because we have only one head turns up. For the last one, both the coins have turned into heads. Because of that, if we define the number of heads as the x random variable, the last one should be capital X is equals to 2. Okay.
Okay.
Then now we have to calculate the probabilities. See, the x values will be 0, simple x. Simple x values means what are the events actually? This random variable x can be 0, that is one event. Capital X random variable can equals to 1. එහෙනම් we have 2 events. Capital X can be either 2, that means both the coins turns into head. Those are the 3. Those are the 3, what we call 3 options. Three situations or 3 events which we can happen. එහෙනම් how we gonna calculate the probabilities? So when capital X random variable is equals to 0 kilogram, total number of elements will be 4. Out of that, only 1 will be selected for this, right? එහෙනම් 1/2. Out of all these 4, we have 2 for this incident. එහෙනම් 2/4. Out of all these 4, we have only one case for this when capital X is equals to 2, that is 1/4. Then the probabilities will be 0.25, 0.50, and 0.25 again. If we draw it in a histogram or the probability distribution, then 0, 1, 2, the x values, simple x values, which we can have for the random variable capital X. Number of headers would be 0, 1, 2. I mark those values in the x-axis. And then for the left side, we have 0.25 or 0.50. That the probability is. Okay.
Okay.
Do we have a question for the... yes, okay. So then what you should know with this discrete probability distribution, all the probabilities of these හරි ඒ කියන්නේ තියෙන හැම situation එකකම probabilities. If we add all the probabilities together on this, it should always adds up to what? It's always adds up to 1. 0.25 plus 0.50 plus 0.25, all the values should adds up to 1. The same thing you can see in the previous example as well. 0.2 plus 0.425 මෙහෙම ඔක්කොම probability values ටික add කළොත්, if we add all these probability values, then it will adds up to 1.0. That means it will equate to 1. Okay. Shall we do the question?
Okay.
So first you have to define the random variable, that is capital X. Then you have to identify what are the values which we can have for this random variable X. Again, random variable X, that means the capital X ke තියන simple X values මොනවාද? In this case now they have already given us 0, 1, 2, 3, 4, 5 කියලා with the probabilities. With the probabilities they have already given. So they ask us to draw the diagram and also answer all these questions. That's the case. Yes, just try. I'll give you some time to do. We'll then discuss.
Okay.
Okay, so what are the values? Did you send me the answers?
Yeah.
Okay, let me check. Okay, probability of x, all these values are 0.9. The missing value would be 0.x is equals to 2. The television value of advertising in punctuation information on color, television ownership in trends in television. Following is a probability distribution for the number of color TVs X owned by randomly selected households with annual income between 15,000 to this one. Use random variable notation to represent the uh, probabilities of each of the following events. At least the household owns at least one color TV. At least one color TV, the probability of capital X should be at least one color now. අඩුම තරම එකක්වත් කියලා කියන්නේ 1 minus 0.009 actually, right? අනිත් පැත්තට ගන්නත් පුළුවන්. Though you adds up all these four together, එහෙම නැත්නම් at least one means one. Then we know all these probabilities should adds up to 1. එහෙනම් 1 minus මෙන්න මේ this event 0.009 because ඒකනේ මුකුත් නැතුව කියලා තියෙන event එක තියෙන්නේ. So 1 minus 0.009 also will give us the same answer. So then we have exactly two color TVs now, that is 0.371 between 1 and 3 inclusive okay, inclusive color TVs. Okay, that means between 1 and 3 කියලා කොහම 1 එකයි 2 එකයි 3 එකයි තුනම add කරන්න ඕන. Okay, very good. Then an odd number of color TVs, odd number of colors කියලා කොහම 1 3 5 තුනම add කරන්න ඕන. Yeah, that's the case. It's clear, right?
Yeah.
Okay. Introducing the mean of a discrete. Okay. Right. Once we can draw the probability distributions and the distribution or a graph with the histograph type, and if we know how we define these random variables, blah, 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 then we should be able to calculate the mean and the variance also for these random variables. Ara api variables වලට කරපු normal variables වලට කරපු හැමදේම we should be able to do with these random variables. එහෙනම් how do we calculate the mean of a discrete random variables, because we were discussing about the discrete random variables. So for the normal mean nang, we just add all these values together and divided by the number of elements. That was the method what we had for the normal mean. එහෙනම් we can add all these values together and divided by this. Now, if it's a random variable, now what we have to do, we have to add all these, how would I say, all these, okay, for the random variable now, so what we have to do, okay, we can say like this. This example is a little bit tough. Okay, so how we gonna calculate the mean value? That is, I'll explain you with this one. Sigma x should multiplied by the relevant probability of x is equals to x. That means, for example, can you see this line? So here 19 should multiplied by the 2 over 8. 2 over 8. Right. Okay. This is a new example. No? Then for the what are the elements we can have? I mean what are the numbers what we can have for this random variable? It can be either 19, 20, 21 and 27. If we calculate the probabilities for the 19, that is 2 over 8. 2 over 8. If it's uh, uh, 20 now, again 3 over 8. 21 now again 2 over 8 and 27 now 1 over. Yeah, that's how it works. Then how do we calculate the mean for these type of ones? It's like a weighted mean. This 19 should multiplied by this probability. This 20 should multiplied by this probability. This 21 should multiplied by this probability and this 27 should multiplied by this probability. That is the method what we have to calculate, what we have for calculation of this mean. There's nothing with the deviations. 19 times 2 over 8 plus 20 times 3 over 8 plus 21 times 2 over 8 plus 27 times 1 over 8. So you should identify first whether the given question is in random variables. එහෙනම් මේ method එකට යන්න ඕනේ. If not, you should go with the normal frequency means and the stuffs. Is it clear?
Yeah.
So then a mean of a discrete random variable will be sigma x multiplied by the probability of capital X is equals to x. The mean of a discrete random variable x is denoted mu x. කලින් නම් mu විතරයිනේ with the population mean නම්. දැන් මේක random variable x කියලා කියන එකේ mean එකට mu x, or when no confusion will arise, simply mu, it is defined as another frequency value, not the frequency value, actually the simple x value. May x value vector should multiplied by the relevant probability value. So the terms expected value and the expectations are commonly used in place of the term means. Those are the theories what we have. Is it clear up to this point?
Yes.
Then for the standard deviation now, again what you have to do, so you should, once we have the mean value of this given random variable, again we should take the difference of this x minus mu, squared deck again, and then each and every one should multiply with the relevant probability value. Once we add all these values together, we can take the square root. If we take the square root, that will be the standard deviation. එතකොට a standard deviation එකේ square එක තමයි, it will be the variance, sigma square. It's clear, right, how this equation works?
Yeah, yes.
You have to take the difference of each and every x value with respect to mean value, whatever we found. ඒක හොයාගෙන ඒකේ squared එකෙන් හැම එකම multiply කරනවා and squared එක calculate කරනවා, and then you have to take the same as the mean value. You have to multiply the given squared values with the respective probability values. That's how we normally calculate it. Okay? Okay. So here note the squared of the standard deviation, that is sigma squared, is called the variance of x. Discrete probability distributions are. So now for these discrete probability distributions, there are 5 discrete probability distributions. One is binomial, the other one is the hypergeometric, the third one is the multinomial, last two will be the negative binomial and the Poisson probabilities. Because according to the actual problem, real problem, we have to select what would be the best distribution method to apply on that context කියලා. හරිද? So මේ හැම එකක්ම discrete distribution discrete probability distributions උනාට we have several again special characteristics on each and every distribution. Either it's discrete probability distribution may have special characteristics තියෙනවා. So once they gave us normally once they give us the problem, we should read it and carefully understand if it's a random variable problem and if it's a discrete random variable problem. Now, what would be the correct method or distribution to apply on those cases කියලා. Okay? So, Q2. So, aren't you have those binomials ඒව මුකුත් නැද්ද? Normal අරත්තන්ට එනකම් විතරයි. Just they are explaining these five, right?
Yeah.
In detail දෙන්නේ නැහැ. Okay. I thought that you... Oh, okay. Shall we do the Q2?
Okay.
Toss 3 coins. එකේ distribution එකක් have they given us? No. Toss 3 coins ne. So you have to write down all the possible outcomes, whatever we have. Akin, you have to do the complete calculation. Okay, just do it.
Oh.
Were you able to figure out?
Yeah, miss.
Are you doing the exercise 13? No, right? Still the coin question.
Yeah, miss, I did halfway. Shall I send?
Okay. Send it to me. And once you complete, okay, so once you complete the, I'll first, okay, send the question to me just to check whether you are on the correct path. Wait, I'm checking. Yes, head, 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 tail, head, tail, tail, head. Okay. Then exists number of very good. When you pull on possibilities, then the number of heads. Now, what are the counts? 3, 2, 1, 0, right? එතකොට x වෙන්න පුළුවන් values වෙන්නේ 3, 2, 1, 0, and then you have to calculate all the probabilities when the capital X is equals to 0, when the capital X is now it's clear, right? The path, the method. Up to this point, it's correct, yes. Did you number of heads? Okay, number of heads. Then step 1. Okay, x is equals to 0. That means only very good. Okay, okay, okay. Once you complete those two, can you do the in lesson 13 exercise? You have the first question and the second question. One more question. Don't you, again, haven't they done the continuous probability distributions as a question? Or මෙතන දැන් නිකං just an නිකං explanation එකක් විතරයිනේ තියෙන්නේ. Are we getting questions from the continuous probability distributions or else not?
Oh, miss, there's an exercise in this
Oh,
lesson.
exercise එකේ, let me show it. So the 13 exercise for the first two nang anyway. Okay, wait. One minute. See this one. The first question is from the probability distribution, discrete random variable. Okay.
Yeah.
So then the second one also from the discrete random variable. And for the third one, they haven't mentioned it. Find the probability. Yeah. Third one also the discrete random variable. 2, 3, 4, 5. Through 2,
Yeah.
3, 4, 5 means it should be discrete random variable. So all these three questions are discrete random variables. Are you sure you are getting questions from the continuous one as well?
Miss, I sent you what we did in the uni for this.
Wait. Uh, um, that means the last image, whatever you sent now.
Yeah.
So how they have defined the expected value of x is defined as expected value of x is, yeah, that is for the discrete ones. That means they are not giving you questions from the continuous one. Okay. That's why මොකද මේකේ මේ දෙක විතරයිනේ, they haven't given us the equation and there are few things you should learn. I think මේක නිකං just for the theory part they have covered it. For this, up to this point, they are only considering about the discrete random variables. Okay. Once you complete the Q2, I mean the 3-coin question, can you do the Q3 as well? That is about for the what we call the dice one. Once you complete those ones, shall we do the exercise? Exercise 30.
Okay.
I'll quickly have a shower and come. Shower means not shower. I'll change my clothes and come quickly. You just do the quiz me questions.
Okay.
Is it done? Were you able to complete? Are you still or else still doing?
Miss, I did the exercise and question 2, but I couldn't do question 3.
Ah, okay, okay. You haven't sent me the workings, right?
I'll send Miss.
Ah, okay. So, wait. Hmm. For the mean calculation, 1 over 8, 3 over 8, 3 again 1 over 8, okay. Then 0.15, okay. If we add all these probabilities together, then it will equal to 1. Ah, oh wait, 1.5 another. No, no. Okay, so for here, all this, if we add all these probabilities, then it will equals to 1. Then to calculate the mean, x is equals to pi 35. Okay, wait. Xi is equals to pi means that is the cumulative probabilities. Is it so?
Miss, I did it in the way that they taught in the uni.
So, in this, so this one, okay, let me open the question. We are doing this, right? So first you have to draw all the 8 ones, okay? No, no, no. No, no.
Miss, in my uni book, there was an equation for this variance.
Okay, yes. So
Yes,
anyway, you have to take the first, you have to add all these probabilities and should divide. No, or make a multiply karan on. That is the calculation, right? Hari, hari, hari. එතකොට ඒත් හැබැයි 0 times මේක 3 times 0.375 no? No, 1 times 0.37. Okay, okay. 2 times 0.75, that is there. And 3 times 0. Ah, right. Hari. For the mean, no? Okay. X times the probabilities. Sorry. So the x times probability is now මේටික add කරා 1.5 මේක තවදුරටත් this is not a probability value. Okay, then එතකොට once we have all these values, so the 1.5 තමයි will be the mean. 1.5 is the mean, and for the variance now what you have to do, for the variance now what you have to do, you have to take the difference in between.
Miss, that equation is correct, right?
No, the equation is not correct now. So that is for the, you have to first take the difference. Difference means, wait. So here the difference is why you do like that? It's the easy one. Give me 1 minute, Imande.
Okay.
Okay, so here what is happening? The question is, okay, how to take your in. So let me take this one. So make a you to calculate now the mean is correct. To calculate the difference, the equation is what? Equation is actually first you have to get the difference of x and xi. That means standard deviations. Now you have to first get the difference in between x and xi. Once you have these differences, you have to square it. So according to the question, x minus, I mean the difference in between the mean and the x values means 1 minus 0.375. 2 minus 0. Sorry, the mean is 1.5, no? 1 minus 1.5. 2 minus 1.5. 3 minus 1.5. එතකොට 3 minus 1.5 get squared. 2 minus 1.5 get squared. 1 minus 1.5 get squared. 0 minus 0. Once we have those values, ඔය difference එකේ squared එක ගත්තට පස්සේ we have to, what we have to do? We have to multiply those ones with the probabilities. ඒක multiply කරන්න ඕනේ from what? 0. Respective one 0.125, ඊට පස්සේ 0.375. Make the probability again 0.375, again 0.125. මෙතන this is not x squared I. This is x minus x bar squared. One difference of 1 and this mean, 2 and this mean, 3 and this mean. That's what they were given, right?
So this is wrong.
Yes, because okay. So what they have, okay, there are two methods according to their given definition. So for the first one is the one what I told you. ඒ කියන්නේ x minus mu ගේ squared එක එහෙම calculate කළා, then initial ones you have to multiply with the probabilities. Once you add all these values together, you can take the square root. Or else what they have done, sigma x squared. Okay. Okay. හරි. එහෙම කරනවා නම් all the x squared values should multiplied by the respective what we call the respective probability values. A probability values were multiply kalla, then we can add all those probabilities together and subtract the mu squared, subtract the mean squared. Okay, that method also correct. Yes. එතකොට whatever you have done, x squared values ටික අරගන්නවා. So ax squared values, okay, x squared values ටික ගන්නවා, x squared pi values ගන්නවා. Okay, then you can multiply these ones respectively, 0, 3 squared and the pi. So 0.375 should multiplied by 4, 0.125 should multiplied by 9. Then you have to subtract the, okay, that method is also correct. So here we have the variance now. Then we can calculate the square root of that variance. That is what we call the standard deviation. Okay, that method also correct. Yes, you can use this one as well. No problem.
Okay.
So the last question means what we have for the last question.
This question 3, I couldn't do that.
Question 3. Okay, in this tute itself, slide.
And the exercise I did, the slide question.
Slide question, okay. For the slide question, now the slide set is this one. Okay, so for this one, Q3, a pair of fair dice is tossed. We obtain the finite equiprobable space S containing of the 36 ordered pair of numbers between 1 and 6. Okay. X assigned to each point A, B, and the S is the maximum of its number. Maximum, S is the maximum of its numbers. Then the random variable X. So how many possibilities are there? 36.
36.
Yes, 36 probabilities. Likewise, the last outcome will be 6, 6. Then again, for the easiest method is you can just find out the maximum number out of these ones. So once you wrote all these 36 outcomes, once you wrote all these 36 outcomes, you can figure out what are the maximum numbers. So it can be 1, 2, 3, 4, 5, 6. So they have defined the random variable X as maximum of these ones. එතකොට පළවෙනි එකේ නම් ඔන්න 1 මේ දෙකේ නම් 2 මේ දෙකේ නම් 3 1 4 නම් 4 likewise you can calculate the maximum number ඊට පස්සේ maximum numbers වල probabilities ගන්න. Is it clear what I'm saying? So obviously 1 වල 1 වෙනවා ඇත්තේ 1 over 36 because the rest of the numbers anyway the other number will be the maximum number නේ. තේරෙනවද මං කියන එක? මේ දෙක 1 කියලා කියන එක maximum number එක වෙන්න එක option එකයි තියෙන්නේ. We have only one option.
Yeah.
That is 1. එතකොට එකයි. එතකොට 1 over 36. 2 කියලා කියන එක වෙන්න 1 2 වලදීත් වෙනවා 2 කියලා කියන එක. 2 2 වලදීත් වෙනවා 2 is the maximum number. 2 1 කියලා කියන possibility එකේ ගත්තහමත් again it will become again 2 කියලා කියන එක තමයි highest maximum number එක වෙන්නේ. So then it will be 3 over 36.
Okay.
Likewise, now you can build it, right?
Yeah.
Okay, do it. Okay, so if you can do it at home, then we can wind up. So we have only the last lesson remaining.
Yeah.
So you did the questions as well, exercise as well.
I did the exercise and I sent you.
Right, okay. Okay, then that's fine. So shall we continue the next lesson next day? Is it okay?
Okay.
The last
Okay.
one with the continuous one. Then everything is done. Do you have past papers to do?
I have
what at least?
4 papers.
4 papers. Okay. Then okay, we are done with the theory part. No problem.
Yeah.
Okay. Okay, then see you next day.
Okay. Thank you.
Bye.
Okay.